Hello, ladies and gentlemen. So we're on to our second topic in our last unit, exponential and logarithmic functions. So we're going to start off with simplifying logarithms, and so we're going to start with a logarithmic expression and condense it down to just an actual value. So two properties we talk about are the zero property and the identity property. So this one basically says if you plug in 1, then that output is going to be 0. So remember that we can talk about logs like this where we show the base. We can even use that special logarithm, ln. And just as a reminder, this is log base e of 1. But nonetheless, we're substituting in 1 here. And this is what we call the argument. So for each one of these, it equals 0. Now the identity is a little bit different. So here notice that the base and what's inside the logarithm are the same. So therefore, the output is going to be 1. So if I put the same base into a logarithm, it gives me back 1. So notice here our bases are the same, our bases are the same. And this one's not easy to see that until we write it like this. So log base e of e, and then yet again that base and the argument, what's on the inside of the logarithm, are the same. So for each one of these, we get 1. Now, as we talk about the domain of the logarithm, there's a restriction, and so remember that we talked about this vertical asymptote. So the graph cannot be 0, and it doesn't go anywhere to the left, to the negative values. So that means that if I plug in 0 or a negative number, my function is undefined. Yet again, negative number. Okay, so one of the properties that we'll use on the next page to yet again get it down to one value is going to be when we're multiplying a logarithm by a value. So here, multiplying a logarithm is going to result in taking this value that we're multiplying on the outside and actually moving it inside, and it becomes the power of what's inside the log. And so just a little connection with vocabulary, the argument is this piece right here that's inside that logarithm. Okay, so to kind of show you what we're going to do, we're going to take this value that's multiplying in front, and it moves and becomes a power on the inside. Okay, so this becomes log base 2 of x to the 7th power. If I wanted to go backwards, I could, and so that I could take this 4 and it moves in front, and it multiplies with the function. So we get 4 times log, let me clean that up, base 3 of x. Okay, one more time. Man, alrighty. Okay, we'll leave it that way. Alright, in our last one, we can use that natural logarithm function as well. And so this would be 2 ln of x. Okay, so now let's put this into action. We're going to get it down to just one value. So here we have some inverse properties, and yet again, it'll tie back to what we were just talking about. So what kind of happens here is that if I have a base and I raise it to the log of the same base, and I have some argument on the inside, it actually equals just the argument. So those parts are canceling out. So here, 2 is my base, and it's raised to a power of the same base. So those cancel out and leave us just 3. Here we have the same thing and leaves us just x. And here, if you remember, so this is log base e of x. So then those are going to cancel out and give us just x. So this is an important property when we come to solving, and we'll see this in our next topic. So the same thing happens here. If it's log b um, of and that argument on the inside is raised to some power a, it equals just that power. And this one actually lends itself to what we just talked about, that we could pull that out, and this would equal a times log base b of b. But what we talked about earlier is that this expression right here just equals 1, so it'd be a times 1, or just a. But so as we apply this, we see a base, log base 3, and on the inside, 3 raised to the 4 power. So those will cancel out, and we're just left with 4. Yet again, solving, we try to get x out of the powers place, and using a logarithmic function is a way to do it. And as we saw over here, natural logarithm has a base of e, so those cancel out. We're just left with x. Okay, and the ones that will probably look the funniest as you work on them is going to be the square roots. So it's remembering that square roots and exponents have equivalent forms, and we call them rational exponents, rational implying that it's going to look like a fraction. So here with this example, I could write it as log base 7 of 7 to the 1/2. So it's making the connection here that that square root is the 1/2 there. And now we can actually pull that power out, or using the property that we just talked about up here, so we get 1/2 log base 7 of 7. But remember that this entire expression here is just 1, um, and we could just get 1/2 times 1. So that's breaking that down a little bit more, and what we can recall here is that those parts would have canceled and given you that as your answer. Okay, so yet again, where we can get it down to just a value. So notice that here we have a third root, so this is log base 2 of 2 to the 1/3 power. So those parts there are going to cancel out, our log base 2 and our 2 base on the inside. And what are we left with? Is just 1/3. So here we have a fourth root, so we get log base 6 of 6 to the 1/4 power. And hopefully you guessed it, that this is 1/4. Yet again, we're going to see that we can apply that inverse property and those cancel out and leave us at power. Alright, so the last example, and you won't see one like this, so don't stress about it too much, but just so that you know that we can work with fractions that are different than just 1 on top. So this would be log base 4 of 4 to the 2/3 power. So if you asked why are the other ones 1, well, remember that 6 would have a 1 power, if you don't see it, of course. So then here we get 2/3. Okay, so that concludes your first part. You have 2 more parts to go through and 3 matching activities.